Okay, so I will start in English right away. So first, my name is not Ivana, it's Ivana. And yeah, it's so great to see you in such large number today, really. And I'm really happy to be a part of this kind of thing, and especially because it's Android-based. So today I wanted to give you a presentation about unit testing with MockK. So maybe first a little bit about myself. I'm Ivana Grkovic, and I'm an Android developer at Vega IT. And since I joined Vega IT, I was working mostly on an e-commerce application, and it is a large scope application with a lot of everyday users. So we always needed to work on apps consistency, stability, with also adding new features because we wanted to satisfy customer needs. And that's why I actually chose to go with this team of testing, because to be honest, until I started all this journey, I didn't know actually how much testing actually meant in these large scope projects. And also when I was communicating with other Android developers, I noticed that some of them are not writing tests at all. Some of them are still, for example, for mocking using MockK, which is a Java version of this, so it's a Java framework. And we all know until practically yesterday, the Java was the language that we were writing our applications in. And currently it's Kotlin, so also some of the guys are using Kotlin and enjoying its advantages. And that's why I wanted to cover today everything, so to go all the way from the basics to the advanced features that actually this MockK library offers. So first I will give you an introduction of unit testing, something about it and what is, for example, mocking and stuff like that. Then I will talk a little bit about the MockK library, its origins, background. I will pass to the MockK features, and at the end I will give you my personal experiences on this theme. So you can... Taman da ja uzmem svoju vodu dok ti to. Njegov pobijate?
A isprobaj da radi sad.
Test.
Ne, čekaj da vidim pa.
Čekaj.
Slučajno gasi.
Hop. Ja smijem ovo staviti.
Ček. Moram ti glasiti. Samo malo. 1, 2.
Sve na najjače.
Ček. 1, 2. A ne znam zašto ne. Samo malo.
Ivana, izvini. Znači, koliko god da se pripremite za prezentaciju, nešto mora da pođe.
Ček. Evo ga. Jel se čuje sad?
Ne. Jel?
Ponovno.
Ja mislim da sam samo ti bio glasan. Test.
Jel čujete sad iza malo, ili? Strah me da mi ne eksplodira opet, samo malo. Oh no. Opet ne respondira ovo.
Nema veze, bolje ovako, bez, da ne gubimo sad.
Probat ću da budem glasnije.
Sorry ljudi, probao sam samo pomoć.
Da li ste me vi uspjeli čuti i koliko? Jeste? Malo, da, potrudit ću se. Uglavnom sve ovo o čemu ću ja trenutno... Switch to English. Okay, everything that I will be talking about the MockK and its features, you can find actually on GitHub, on the MockK repository. So first I wanted to cover the term of unit testing. So what unit testing actually means and does. So unit testing is a software development process in which we take one particular part of our application, in most cases some classes, and then we separate them and individually test them for their behavior. So this is really useful because we can detect issues early on, so when we are adding new code, but also it is always good to have our code always covered with tests, so that way if we change something in our application with, for example, adding new features or something, we will have this code actually covered, and then when executing the test we will see if we actually broke something or didn't. And we can actually create these unit tests, and we can run them manually. So we can run them manually every time we change something. But that's not always a good solution, because first, I'm not the one trusting in myself that I will do it every time when I do some little change or something. So it's always a good idea to have automated tests. And for example, in my project happened one situation when we needed to change just one line of code. So there were like the product list, and then were the product images. So first were the product images, and then the images of the variants of that product, so the sizes, the colors and stuff. And my colleague, when he was working on this, he somehow just swapped these two lists of images, and then we first got the color images and then the product images. And he didn't run the test locally. He opened a merge request, and his pipeline failed because the order wasn't right. And in that case, we probably wouldn't notice that, and it will reach the production, and maybe the users would be the one noticing that. So that's why I say it's always a good idea to have automated tests to back you up. And the way that we are doing so in my project is by having these workflows of executing our tests as a part of our CI/CD lifecycle. And we are using A/B tries for that. So every time we open a merge request, we fire a pipeline which has this code, this actual block of, and then it executes all of the tests in our application. If in one test in our application fails, then we are not able to merge it. Now moving on to the term of mocking. So what does mocking mean? So mocking is creating objects that simulate the behavior of real objects. And when I was talking about unit testing, I mentioned that we are taking one part of our application, and then we just want to test that one part by its behavior. And that way, most often than not, that part will be dependent on other classes or other objects. And we want to keep the instances of these objects as not as real objects, but as some kind of copies of them or dummies, so that we are the best way that we isolate the behavior of our object that we want to test. And also, the good thing with that is that we have these dummies of these other dependencies, and that we can say to them what they need to do. So we can create different scenarios so we can better test our object that is under test. Moving on to the MockK library. So the MockK library is a library written in Kotlin, and it's written for Kotlin. And it's an open source library which is released in 2017. And it's created and maintained by just one guy, and it's Oleksey Pilipenko. I'm hoping I'm pronouncing his name right. And he is still maintaining it. He is still working and fixing some issues, adding new features. So, I mean, I think for a month he adds 2 new features. So maybe until next year we can revisit this presentation and see what's new with MockK. And we can find his repository on GitHub. So when we say that MockK is good for Kotlin, we actually mean that it supports some of the most important features that Kotlin offers. And by that, for example, we have these kind of Kotlin specifics, so final classes and functions. So we all know that in Kotlin, all classes are by default final. And that was a problem, for example, for Mockito, which was used by Java, because with Mockito relies on subclassing when it's creating these mocks, and the MockK works by creating a proxies of them. So the final is not an issue here. And for example, if you wanted to do it with Mockito, you would need to create to make all of these classes actually open to do so, and that's not a good solution. Also, object mocking. So with objects, also it's static, and Mockito doesn't support mocking of the statics. So if you wanted to, for example, mock an object, you would need to create an interface, then specify the same functions in that interface, and then extend your object with them, overriding these methods. And it was a lot of boilerplate code just to do one simple thing. And it's more simple to do in MockK with it. And also we have these 2 Kotlin specifics, which are extension functions and coroutines, and we will see later how it is done in MockK. So let's now see some code. We have one simple test here. Okay. So we can first see the syntax that when we are writing these unit tests with MockK, it's always good to go with sentences. for function names, because that way it's more readable and we can see actually what our test needs to do and what we need to actually find out in the end. And we are always going with keywords actually. Given some condition, when doing some action, then what are we expecting our test to retrieve. And by doing so, we need to add these backticks at the start and at the end of our functions. So now here we have our class, which is system under test, and that is the class we want to test. And we see that it has two dependencies. And we says that for these dependencies, we need to keep them as dummies. And these dependencies have their values, which is some integer, and our function has this add function, which add these two values together. And now let's see how we test this so that we see that at the end our function result is equals as we are expecting them to be. So first we need to create mocks of our two dependencies. So we say dependency 1, mock dependency 1, then we are mocking the dependency 2. So we are creating these mocks. Then we need to stop them, so we need to tell them what they need to do. And we say that every time we are calling this dependency 1 and we are asking for its value, we are returning a 5. So we are saying the dependency 2 value that always needs to be 5, and that for dependency 2 value, it needs to be 6. After that, we need to create a real instance of our object. So we say system under test, and then we are passing in this dependency 1 and dependency 2. Then at the end, we need to assert that something happened if it was something we were expecting. So we say that the expected result is 11 because it's a sum of 5 and 6. And at the end, assertion, so we are asserting equals that this expected one was the same as the one that we actually retrieved with this add function. I will give you a few moments to take a look at the code. So now talking about syntax, we can notice that this syntax is the same as for the other mocking frameworks. So in the first part, we were defining our mocks, then we are stubbing our calls, then we execute the code to test, in our case the add function, and in the end we are verifying its correctness. Now we have two types actually of mocks, and it's strict and relaxed mocks. And by default, the mocks are strict. So if the behavior is not specified for these mocks before execution, we would face the following exception. So if we didn't say the dependency 2 needs to return a 6, we will face this exception because these mocks are, how can I say, really dumb, and we really need to tell them what they need to do. And there is another type, which is relaxed. If we want to overcome this and not get this error, we would need to say now that this dependency 2 is, we say relaxed equals true, and that way we make it relaxed. And what that does is that every time we are asking for something for the dependency 2, we get a dummy stub. So in this case, if dependency 2 value was integer, we will get a 0, like something really, really simple. And if that integer was actually nullable, we will get null in that case. So because it's not nullable and we expect a 0 from it, what will actually happen when we are executing this test? It will happen that it will fail. Why? Because we didn't specify that it needs to return 6, and it will actually return 0. So, and then we have this dependency 1 value being 5, dependency 2 value being 0, and that will bring us a result of 5, and we are expecting 11. Now another term, which is really common, is a spy. This looks weird, but okay. So with spy, spy returns a copy of an actual object, as opposed to mock, which returns a dummy. So it's kind of something similar to mock, but instead, for example, when we are asking for something from it, we will get the real result. So it will behave as expected, as it would normally do. And with dummy, we either get the exception or we get some dummy stub. So spy allows mocking a particular part of it. If we want, for example, to keep everything as it is and just mock one function. and that gives you the control over the object, so what needs to be mocked and what doesn't. So we can see now how it's actually done in a test. So we are sticking with the same values. We have the dependency 1, dependency 2, and now we want this dependency to be a spy in this case. And if we say that this dependency 2 is a spy, we need to provide the real instance of it to it, and we are saying dependency 2, its value is in this case 6. And if we didn't specify this line, what it needs to do, this test will succeed, because even though we are not stubbing it, it will return a real result. So we will get 6 and a 5, and it will be 11. But in this case, as we said, we can also mock it. So if we stub it to the result of 7, in this case it will be 12, and this test will fail. So now we want to make sure that our object under test is behaving as expected, and we can do so by using these statements. And one of these statements is verify statement. And we can see now how it's done with that. So verify statement, I'm missing a bullet here, but I don't know, maybe it's something in the format of the presentation. What verify actually does is that it checks if the calls have been made. So in this case, if we want to check that when we are executing this add function, we want to check if the dependency 2 value has been actually fetched, and we can do so with the verify. So we are sticking with the same thing when we are calling this add function, and at the end we say verify dependency 2 value. So in this case we are not verifying what will return, but if it actually will be triggered, and when we are calling actually this add method and dependency 2 value, we will see that it will actually be called, and this verify statement will be true. So this test will pass. Also, with these verify blocks, we can also pass multiple functions to them, so not just one. So it allows grouping more than one method inside. And if we change this a little bit and we say that we now have a calculate function, and then we have add and multiply functions, and we want to say that we want to check if every time we are calling this calculate method, we are actually calling multiply and add functions, we will do it the same way. So we'll just say verify, and then inside of this we will just pass the two of them, and this will also succeed. Now with verifying the order, so there are a lot of ways to verify the order of these methods that we passed in. So first we can verify if all of them happened. We can verify the opposite of the verify statement if one of them was not called. For example, if we have some check in our code and we want to skip something in some class, then we have this verify order and verify sequence. So now if we have a calculate function, and we have these three functions, multiply, add, and subtract. For example, first we want to check if the order is correct, so we are saying verifying order, and because the order was indeed multiply, add, and subtract, this will succeed. If we call verify order with multiply and subtract, it will also succeed, because we skipped this add, but this was indeed the order that they were called in. But when we are verifying the sequence, we are verifying the sequence of these calls when it happened, and if we leave one out, this will fail, because the sequence was actually multiply, add, and subtract functions. Another thing with these verify statements is that you can actually pass arguments to them. So we said until now that verify statement verifies that the call has been made. But we also can verify how many times it has been made. So we can say, we can pass an argument, for example, at least how many times we expect that it happened, at most how many times, and exactly how many times it happened. Now another thing that can be used with these verifications, but also can be used with stubs, is mature expressions. And I put some here, so there is a large list of these mature expressions, and you can actually find them in the GitHub profile of this repository. So what are actually mature expressions is that they are placeholders that are used to specify which values can be actually used in a function. So we can have more control over these variables that get passed into the function. So for example, with these matter expressions, I can say this for every time we are calling the add functions. For example, with a number between 0 and a 5, return some specific result, and for the range of 5 to 10, return another result. So we can specify ranges. This way we can specify regexes or any arguments that can check if our arguments fall into this certain scope. And as I said, they can be used with stubs and also with verifications. We will see one in an example really soon. Another term that I wanted to cover was argument catching. So this is also a good thing to have when writing tests, is that you can actually catch a value of an argument that gets passed in one function, and you can access it later. So for example, now we want to check. Now we did the dependency 2, and we are passing in this number to the calculate method and also in the multiply and the add functions. And we want to check if the number that we passed into the calculate method was indeed the number that we got into our multiply and the add functions. And we can do that with argument exceptions. So we can see now how. So we need to specify a slot. So this is currently a slot of integer because this value was an integer. This can also be another type. It can be a list as well. And we can say, for example, if every time we are calling this add function with a slot return 15, and then we say capture, and in this case we are saving it to our variable, and then we can access our calculate method. So we can say calculate with the number 5. And then we want to check if this actually happens. So first the verify block, we are verifying if the add function has been called, and then we are asserting equals that this slot that we captured before was actually 5. So that this integer that got passed into the add function, and this will also succeed. So we can also catch an argument with this with arg. And what is with arg is that is also a matter expression that I mentioned before. So we can say how we can see this same thing with using matter expressions with arg. So in this case, we don't need a slot, so we are not doing it with a slot. And we, for example, say here that every time we are calling the add function with any parameter, we return 15. Then we are calling this calculate method. And similar to the before, we have the verify statement. We are verifying that the add function has been called. And in the end, we are asserting equals. So we are saying with arg, and then we can access this argument that got passed into this add function. And we are asserting that it was indeed 5. And this will also succeed. Now, in the start, I mentioned some of these Kotlin specifics that MockK is so great about, and one of them was extension functions. So we can see now how extension functions can be mocked. So they are dispatched statically, so they are a little bit harder to mock. And we have two types of dependencies. I mean, they are not really types of dependencies, but where they are placed, and the mocking differs for them. So, for example, we have here a extension functions that is a part of one class, and when we want to mock actually this extension function, we need to mock the whole class that contains it. So we mock this example class that is above it, and then we say with this example class, and we can then do it normally as we would. So we are saying that every time we are calling this concat function above any string, we return a specific result. And in this case, we have a top-level function, so it's not part of one class, it's part of some file. And we can also mock it, but we need to first say this mock static, so we need to create a static mock of that file, and we need to specify the path to it, so the package where it is located, then the name of that class, and at the end kt as a suffix for each class that we want. And then we can do the same thing as we did before, so we can say that every time we are calling this concat function above any string, we return a specific result. Also, another Kotlin specific was coroutines, and we can see now how coroutines can be mocked. So they can be mocked by just adding a co-prefix mostly, so it's kind of similar as for the normal functions. Just when we have some suspending function, we can actually replace this every statement with co-every, and this verify statement with co-verify, and it does the same job, and it's kind of the same, but they're taking suspend lambdas instead of regular lambdas, so that's only difference for them, and we can see it now in an example. So now let's see that there are functions that we had before, add, multiply, and calculate for actually suspending functions. So how we can verify that these calls were made. So instead of just saying verify, we are calling co-verify. And when we are calling our calculate method, we just say run test. And run test is something similar to run blocking, but it skips delays, so it gives our tests a little bit more time. So it's always good way to go with run test for this, and it's the same. So it's the same as you would do with normal functions. Ooh. And also another thing is object mocking. So object mocking, I mentioned before how we would actually do this in Mockito. So we will need to create this interface, then extend and override its methods and whatnot. And it's really, really simple with doing it with MockK. So it's similar to mocking the regular classes. So now I will show it in the example. So for example, here we had before the dependency one being a regular class, and now it's an object, and we have this function here now that returns a random int, for example. And then how we can do the same thing as we did before for our first test is first we say mock object, then we pass in dependency one, so we are mocking the dependency one object, and this was how we were doing it with the class. Then we are creating a real instance of our system under test, passing this dependency one, and then we say that every time we are calling this get value. For example, we return 5, and we will get a result that we want, so this assert equals will actually succeed. But one thing that is different between mock objects and classes is, for example, if you see here is an uppercase for the dependency one. So this object is in this scenario behaves like a real object. So it's something similar with the spy I mentioned before. So you don't need to specify the behavior for it. So if I didn't wrote this line, it will actually, the test will, I mean, it wouldn't pass, but it will be okay, it will build. But it will return a random int, so it will give us a real result, and that's the thing with objects that is different from the classes. And we have almost reached the end, and in the end I said I will give you my personal experiences when using a MockK library. So I can say that using MockK library was really, really pleasant experience for me. Because it really suits Kotlin language, and it covers all the Kotlin specifics, and that way you can have the freedom to do anything you want. You can experiment, you can write some tests, I don't know, do some changes and stuff, because there are really a lot of features that are in this library, and it's still evolving, so maybe it will be more in the future, so that's always good. And when we are talking about it, this is so when we are facing some issue or we have some ideas for improvement, we need some feature in order to do something, we can actually leave a feedback to this GitHub profile, and I noticed that it gets solved really, really quick. So that's always a good thing. And the only downside that I wanted to mention here is the tests can take some time to run. So of course you won't notice this when you have just one test and you run it and everything will be fine. But for example, if you have 100 tests in your code, you would notice that it can take some time to run. And in this case, it's always good to do, and this happens actually because of the caching. And it's always a good way to, at the end of your test classes, you can specify clear all mocks and unmock all objects, just so you can delete this cache, and each time it will actually open a new class, then it will be solved, and in this case you won't get these caching issues. So that was everything. I hope you learned a thing or two, and if you didn't, if you haven't written tests until now, I'm hoping I inspired you a little bit to do so. And also, if you are still using Mockito, I'm hoping I gave you some examples to switch to MockK. Thank you. Any questions?